Section 10.5 is on hyperbolas. A hyperbola is the set of points P in a plane such that the absolute value of the difference between the distances from P to two fixed points F1 and F2 is a constant K. So this is a little more complicated than the other conic sections we've taken a look at. So what this is saying is that there are two foci, F1 and F2, and that the distance from F1 to P minus the distance from F2 to P, the absolute value of that is always going to be the same no matter where that point on the curve is. You'll also notice that unlike the other graphs of the conic sections, the hyperbola has two separate curves. In this case, it has one opening to the left and one opening to the right. Let's take a look at some of the aspects of a hyperbola, and then we'll take a look at a picture. I wouldn't worry too much about the strict definition right now. So, as I said, a hyperbola always has the two separate curves. Each curve has a vertex, so it kind of would be in the place where the vertex is on a parabola. The segment connecting the two vertices is called the transverse axis, and its length is 2 times a. The midpoint of the transverse axis is the center, and inside the bowl of each curve is a focus. Perpendicular to the transverse axis, we have a conjugate axis, and its length is 2b. These two axes determine a rectangle whose diagonals are the asymptotes of the graph. As with ellipses, a hyperbola can either be horizontal, meaning it's opening left and right along the x-axis, or it can be vertical, opening up and down along the y-axis. So let's take a look at this text box from your textbook. So for a horizontal parabola, you'll notice it's opening left and right, okay, opening along the x-axis. Okay, we have the vertices right here, kind of at the where they would be if this were a parabola. The focus is inside the bowl. This blue line going across the center here, that's your transverse axis. The vertical line here is your conjugate axis, and you'll see that those create a rectangle. Now the rectangle, any of the green lines here are not a part of the graph of a parabola, but they're important things to draw in order to draw the graph of the parabola. So those create a rectangle. The diagonals of that rectangle are the asymptotes that the curve approaches but never touches. The equation for a horizontal parabola is x squared over a squared minus y squared over b squared equals 1. You'll notice it looks very similar to the equation for an ellipse, except that it has a subtraction in the middle here. Different from the ellipse, a does not have to be greater than b. For a hyperbola, the way you know if it's horizontal or vertical is which letter x or y comes first. So in this case, the x squared is basically the x squared minus the y squared. So that means it's going to be horizontal and open up on the x-axis. Notice here for a vertical hyperbola, the equation is y squared over a squared minus x squared over b squared equals 1. The y comes first, so this opens up on the y-axis. It opens up and down. And all of the same things are true. So in this case, your transverse axis would be up and down. Your conjugate axis would be left and right. And again, you have the rectangle that determines the asymptotes, which determines where the curve goes. Let's take a look at an example. It's a little easier to figure out if you're actually just doing it. So this says, write the equation of a hyperbola centered at the origin with vertices plus or minus 2, 0, and one focus at 3, 0. Then graph the hyperbola. Well, let's start by graphing some of these points. So I know that that's going to be a vertex and that's going to be a vertex. I'm just going to put a little V there so to remind me of that. And then I'm going to have one focus here at 3, 0. So that tells me that this is actually going to be a horizontal, so it's going to be opening to the left and to the right. So this is going to be a horizontal, and its basic form is going to be x squared over a squared minus y squared over b squared equals 1. So I need to find a, b, and I think I already know c. So I know that my transverse axis is going to be going along the x-axis. So that means that the distance from the center to this vertex here is a, so a is equal to 2. B is going to be 1/2 of the conjugate axis, which is going up and down, but I don't know what that is yet. Okay, and I do know that my c is going to be 3 because c is the distance from the center all the way out here to a focus. And then I know I'm going to have another focus out here at -3. Okay. Oh, I didn't mention it in the last one, but for this, remember that for an ellipse we had c squared equals a squared minus b squared. For a hyperbola, it's basically the Pythagorean theorem. C squared is equal to a squared plus b squared. So doing that, 9 is equal to 4 plus b squared. So my b is going to be equal to the square root of 5, which is approximately 2.2. I'll put it over here as the square root of 5 so I can write my formula, but to graph, I'm going to need to know that that's about 2.2. Actually, I could go ahead and write my equation right now since I have my a and b. X squared over 4, because that's a squared, minus y squared over 5 is equal to 1. There's my equation. And now let's graph it. So I have my transverse axis. Now I need my conjugate axis, which is going to be about 2.2 units up and 2.2 units down. Okay, and then I'm going to go ahead and draw my box. Remember that this rectangle is technically not a part of the hyperbola. Okay, but that determines where it's going to go. And then the diagonals of this rectangle are going to be my asymptotes. And I need to have the asymptotes to graph it. Okay, and it's going to open left and right. So for my vertex going out this way and going down that way, and for my vertex going this way and my vertex going that way. And that's the graph of the hyperbola. And our last example says, find the vertices, foci, and asymptotes of the hyperbola whose equation is 4y squared minus x squared equals 16, and then graph the hyperbola. You'll notice that this is not in standard form. This is actually in general form, so I need to rewrite it in standard form. And as we saw with an ellipse, standard form of the equation always equals 1, so I need to divide everything by 16. So that's going to give me y squared over 4 minus x squared over 16 is equal to 1. You'll notice that y comes first. It's basically y minus x, so that means this is going to be vertical, which means it's going to be opening up and down, so it's going to look like this. Okay, and this is a squared, this is b squared, so a is equal to 2, b is equal to 4. Let's figure out what c is, since I'll need that for my foci. So c squared equals a squared plus b squared, or c squared is equal to 4 plus 16. So c is equal to the square root of 20, which is equal to 2 square root of 5. Let's go ahead and graph. So since it's vertical, my a is going to be up and down, so I'm going to have a vertex at 2 units up, a vertex at 2 units down, and then my covertices 4 units to the left and the right. Those are going to create my box, which I will just dash. These create my asymptotes, the diagonals of that rectangle. Okay, and I know this opens up and down, so it's going to start here at the vertex and go out like this. Start here at the vertex and go like that. And the same thing here. Okay, so my foci are going to be points out here, kind of up here. That's going to be a focus there. I don't know exactly what. Actually, it's going to be a little further. That's going to be more than 4. So I'm going to go ahead and put my focus. Square root of 16 is 4, so this is going to be a little bit more. So I'm going to have a focus here, and I will have a focus here. Let's see, 2, 4. There we go. Right there. Now those coordinates, notice that my x coordinate is going to be 0. So the coordinates of my foci are going to be 0, 0, and then plus or minus 2 square root of 5. Don't do that. Okay. Oh, need to identify my vertices. I didn't do that yet. Let's do the vertices. My vertices are at the points 0, plus or minus 2. And then I need my asymptotes, the equations of those slanted lines. Okay. Now, there is a formula you can use for this, but I usually just look at the graph. So what's the equation of that line? Well, it goes through the center, so its y-intercept is 0, and I went up 2 and right 4. That's a slope of 2 over 4. So 1/2 y equals 1/2 x is the equation of that line. Notice this one has the same slope, but it's negative, so my asymptotes are plus y equals plus or minus 1/2 x. So those are the things I was asked to find. And there's your graph of your hyperbola. So in this section, we took a look at hyperbolas, only those that are centered at the origin, how to graph them, how to write their equations. A lot of details involved with this, but remember, if you can figure out where the vertices are, where the covertices are, use that to draw this rectangle, use the rectangle to draw your asymptotes, and then the graph is actually not the rectangle in the asymptotes, but the curve that either opens up and down or right and left, as we saw in the previous example, that approaches those asymptotes.